Welcome to today's lecture. The subject is chemistry. Today we'll be looking at acid base indicator. The topic again is acid base indicator. An indicator is a substance that changes color depending on the pH of a solution. It helps one know whether a solution is acidic, neutral, or alkaline. Common indicators and color changes. So the indicator we want to consider are litmus, methyl orange, and phenolphthalein. This neutral here could also be taken as endpoint during titration. Okay, so we're taking this neutral as endpoint during titration. Don't forget, the endpoint is that point where a base completely neutralizes an acid to form salt and water. Okay, so at that point we say the solution is neutral. Okay, so for litmus, under acidic medium it is red, the neutral is purple, that is at endpoint is purple, the alkaline medium it is blue. For methyl orange, under the acidic medium it is red, under the neutral is at endpoint is orange, alkaline medium it's yellow. For phenolphthalein, acidic medium colorless, at endpoint colorless, and alkaline medium it is pink. Choosing the correct indicator. If you have a strong acid and a strong base, you can go with any of the indicator. That means you can go either methyl orange or phenolphthalein. If you have a strong acid and a weak base, the correct indicator to use is methyl orange. If you have a weak acid and a strong base, the correct indicator to use is phenolphthalein. pH scale. Our pH scale ranges from 0 to 14. So if your pH is less than 7, then it is an acidic medium. If it is equal to 7, that means the medium is neutral. If it is greater than 7, then it's an alkaline or basic medium. This will take us to pH calculation. pH is the negative logarithm of hydrogen ion concentration. That's pH is the negative logarithm of hydrogen ion concentration. The formula for pH is negative log of hydrogen ion concentration. If you don't want to put a minus sign there, you could also write it like this. That means the minus is no more there. We can also represent the H plus with H3O plus. And then when we write that this way, we can also interpret it this way too. So please take note of the various methods of writing the formula. H3O plus is called ozonium, hydronium, hydrozonium ion. So any of the name can go. Ozonium, hydronium, hydrozonium ion. The pH of acids are calculated directly by using the formula, as the formula is tied to hydrogen ion. So we can say pH is negative logarithm of H plus, hydrogen ion. So for acids, you just calculate the pH directly. However, for bases, you would have to go and calculate the pOH. The pOH is a negative logarithm of hydroxyl ion concentration. That is, POH is negative logarithm of OH minus. We can also write this in this format. That is, POH is log 1 over OH minus. Relationship between pH and POH. Your pH plus POH will give you 14. So let's look at an example. Calculate the pH of 0.001 mole per gm cube H2SO4. When you are given a question like this, you would have to carry out the dissociation of the acid. Okay, H2SO4 dissociates to give you H plus SO4 2 minus. Don't forget you have 2 atoms of hydrogen, so you have to balance it up. So it means that the acid here compared to the hydrogen ion is ratio 1 to 2. So if the acid given, the concentration of acid given is 0.001 mole per dm cube, it means the concentration of hydrogen ion will be 2 times what is given here, which will be 0.002 mole per dm cube. Okay, so you quote the formula now. pH is negative logarithm of H plus. Of course, we have 0.002. Now, you will convert 0.002 to standard form. That is 2 times 10 raised to the power 3. 2 times 10 raised to the power minus 3, that's minus 1, minus 2, minus 3, since you are coming from your left. Okay, so applying the law of logarithm now, leaving the minus sign outside. Okay, that will be log 2 base 10 plus log 10 raised to the power minus 3 base 10. Okay, don't forget there's a base here. There's a base here. The base is 10. Okay, it's base 10. This log is given with respect to base 10. Okay, I introduced the base there to help us understand better. So this will give us log 2 base 10. There's a minus 3 there. The minus 3 comes here to form minus 3 log 10 base 10, applying the law of logarithm. Okay, so log 2 base 10 is 0.3010 minus log 10 base 10 is 1. You will need to commit this to memory. Log 2 base 10 is 0.3010. Log 3 base 10 is 0.4771. Log 5 base 10 is 0.6990. Log 10 base 10 is 1. You need to commit these values to memory. So back to the question. Log 2 base 10 is 0.3010. Log 10 base 10 is 1. So if you multiply that, you will get 3. So we open the bracket. We clear the bracket by using the minus sign. That will give us minus 0.3010. The minus times minus, that's 3. That will give us 3. And by the time we resolve this, we'll get 2.699, which is approximately 2.7. We look at question number 2. Calculate the pH of 0.0015 mole per gm cube calcium hydroxide. Of course, it is not an acid, so we cannot calculate the pH directly. So we need to go and get the POH. The POH is the negative logarithm of hydroxyl ion concentration. This contains the hydroxyl ion, so we start from that point. POH is negative logarithm of OH minus. So we write the base and carry out the appropriate dissociation equation. And so if we do that, we're going to get Ca2 plus 2OH minus. So if the concentration of calcium hydroxide is 0.0015, of course, looking at the ratio of the base to that of the OH minus, it is ratio 1 to 2. So if the concentration of calcium hydroxide is 0.0015 mole per gm cube, that of the hydroxyl ion will be 2 times that value. That will give us 0.003 mole per gm cube. And so we put that value now into the very formula. Okay, converting this again to standard form, that will give us 3 times 10 to the power minus 3 as minus 1, minus 2, minus 3. That's 3 times 10 to the power minus 3. Applying the law of indices, leaving the minus sign outside. Okay, multiplication in indices is addition. So just break it down. That will be log 3 base 10 plus log 10 to the power minus 3 base 10. Of course, log 3 base 10 is 0.477. I told you to commit it to memory. And this minus 3 comes there to multiply. You have 3 log 10 base 10. Of course, you clear the bracket with the minus sign outside. You're going to get to this point. Don't forget, we're not to calculate POH. We're to calculate pH. So pH plus POH is 14. So pH is 14 minus POH. So pH is 14 minus 2.52. So eventually we have 11.48, which is 11.5. We go to question number 3. Calculate the hydroxyl ion concentration of a solution of H2SO4 with a pH of 3. We are to calculate the hydroxyl ion concentration. Of course, our pH is negative logarithm of hydrogen ion concentration. The pH is 3. We're using this formula now because we're dealing with an acid. So 3 minus log H plus, that is negative logarithm of hydrogen ion concentration, of course, to base 10. We will need to recall this very law in logarithm. This is the initial form, logarithmic form, base a to power x equals p. If we are to convert this initial form to logarithmic form, that will be log p base a equal to x as it is written. So we'll apply this knowledge here now. Here we have minus 3. That means you multiply both sides by minus. So minus 3 is log h plus base 10. So base 10 raised to power minus 3, look at it again, a raised to power x, base a raised to power x equal to p. So it means base 10 raised to power minus 3 equals to h plus. Of course, H plus, which is the concentration of hydrogen ion, is 0.001 mole per dm cube. Concentration of hydrogen ion multiplied by the concentration of hydroxyl ion will give us 1 times 10 to the power minus 14 mole squared dm raised to the power minus 6. So the concentration of hydroxyl ion will now be this minus that value. And eventually we have 1 times 10 to the power minus 11 mole per dm cube. Alternatively, that's method 2. We know that pH plus POH is 14. So the pH given is 3. And then our pH will simply give us 11 after going through this process. So our POH is negative logarithm of hydroxyl ion concentration. The POH is 11 minus log OH minus. So base 10, don't forget there's a base there, base 10, okay, raised to the power minus 11, which is this, base 10 raised to the power minus 11 will give us OH minus. So eventually, that will be 1 times 10 raised to the power minus 11 mole per dm cube. That's the second way of doing it. We look at the last question now. The pH of calcium hydroxide is 10. Calculate the concentration of calcium hydroxide. Of course, pH plus POH is 14. pH is 10 plus POH is 14. So our POH is 14 minus 10, which is 4. Of course, the POH now, which is 4, is minus log hydroxyl ion concentration. And so base 10 raised to the power minus 4 is this. So the hydroxyl ion concentration, if you resolve this, you will get this. Now, we're looking for the concentration of calcium hydroxide. So we write the dissociation equation. What we have now, or what we have found, is this aspect, which is, if you look at it, The ratio of the base is 1, that of the hydroxyl is 2. So I'm looking for this now, having known the concentration. So if you cross multiply, 2x is this. So x is 0.001 over 2. X will be 0.00005 mole per gm cube. I'd like you to go through the process and understand what I have done. It's a little bit technical. If you look at it, okay, what we found was OH minus, which is this. Don't forget the mole ratio there is 2. The mole here is 1. So 1 here to 2. So we're looking for this, which is x, and that of this is 0.0001. We did this in stoichiometry, if you remember. So if you cross multiply, 2x is that, and then you finish up. I would like you to look at the following exercise. Question 1. Calculate the pH of 0.0002 mole per gm cube NaOH. Calculate the pH of 0.0002 mole per gm cube NaOH. NaOH, that's sodium hydroxide. Number 2, calculate the pH of 0.005 mole per gm cube HCl. Number 3, calculate the hydrogen ion concentration present in a solution of KOH with a pH of 11. I'll see you in the next lecture.